Can anyone hear me?
Hello. Good
Great.
morning.
Thank you. All right. So let's start with the syllabus slash schedule. Today is March 17th, St. Patrick's Day. Uh, Happy St. Patrick's Day. Today we're going to start studying the collections framework. And are there any questions before we begin with that? All right. So let's look at the let me go back to this again. So let's just take a look at where things are going. So today is collections framework. Wednesday is collections framework, and Friday is collections framework, and we have the Tombs of Mars lab. Then we have data structures for a week, and the worm dissection lab. And then in the beginning of April, we have 2 reviews and an exam. So you have another exam coming on April 11th, as well as a final project of 700 lines. So these are 2 landmarks to keep in your brain as you're studying and working your way through classes. Any questions? Okay. All right. Collections framework. You might want to mute your microphones if you're not speaking. All right. So let's take a look at this. So the 2 of the main structures we want to talk about are stacks and queues. So a stack has a push that puts things at the end, and a pop that removes from the end, and a LIFO, which is a last in, and that's described by the word LIFO. So it's last in, first out. So the thing, if I put things in, it's like I have a laundry bin, right? And I put things into the laundry bin. And when I go to take things out, I'm going to take out the last thing I put in because it's sitting on the top. Okay. A queue, on the other hand, is you have it adds at the end. It has an add that puts at the end and a remove that removes from the front. And this is a FIFO, or a first in, the first out. So this is more like you go to you go wait in line at a grocery store, and you all get in a line, and whoever got in line first gets served first. And the British even call this queuing. So that's a queue. And then the queue is an interface. Unfortunately, Stack isn't. It's sort of an oddity of the way the Java API was built. It should have been, but that's the way it is. Then there's also a class called Java util linked list, and that has add first, add last, remove first, remove last, and you can use it either as a LIFO or a FIFO. It implements queue and can be used as a stack, but again, stack isn't an interface, so it can't implement it. And then I have a code, which you can look at, stack and queue, which looks like this. And what that does is we import Java util star, and then we take a queue of integers, and we implement that with a linked list. And then we say for I equal 0 to 5, we say q.add, and then we say, well, sorry, while the queue is not empty, we remove the item and print it. Then we print a blank line. And now there is a thing called a deck, which is a double-ended queue. And it has the push and the pop methods on it. And so we're going to use, and that's an interface. So we're going to use that in this example. And if I just copy this code, You see with the queue, things come out in order because they go in. Sorry, the deck is implementing a stack. So with the queue, things go in order, but with the stack, things come out in reverse order. Because I'm taking out the last thing I put in. Does that make sense to anyone? I see you have a question in the chat. Is it cutting in and out for anyone else? I'm sorry if there's a problem with the audio. I don't know why there should be. Does anyone have a question? Maybe they didn't hear something and they want me to repeat it. I see. Well, I don't think there's anything I can do about that. Yeah, okay, so a stack, excuse me, a stack, in this case, we're using the deck class as a stack. It has a push and a pop, right? And it's like a laundry bin. I put things in, I take things out, but whenever I take things out, I'm taking out the most recent things I put in. Because that's the way a laundry bin is. The first thing I put in is on the bottom, the last thing I put in is on the top. So a stack is a LIFO and a queue is a FIFO. Does it make sense? Does that answer your question? Like the Tower of Hanoi, I guess. Okay, so anyway, that's the basic concept of a stack and a queue. And these are two types of collections that you're going to use in your programming life. Okay. And there are some other ones. One is the priority queue. And this is a object that's built on something called a heap. Heaps are beyond the scope of this course, but I encourage you to look up how they work. A heap, a priority queue allows you to add or remove something in order log n time. And the concept of a priority queue is when you take something out of the queue, it takes the thing with the highest priority first. Okay, so every time you put something in, it has a priority. It has a sorting order, and it wants to take the lowest thing first. And I did not make this a link, so let's fix that. Oh, I probably can't fix it. All right. So now when I'm looking at this, when you're looking at this, you can click here and go to this code. And what this is going to do is it's going to create a sequence of random numbers. And it's going to add them to the priority queue. After it's done adding them, it's just going to print 3 equal signs. And then it's going to go through and remove everything from the priority queue. And what's going to happen is it's going to print out these random integers in sorted order. See, it prints them out in sorted order. And you notice that it takes log n to insert and log n to remove. And you have to do these things n times in order to fill the queue and empty it. And that amounts to a sort. And that's once again n log n time. Just like you would get with a quick sort or a merge sort. Any questions? Okay, no questions. Oh, wait, I see something in the chat. Yeah, so the way it sorts the numbers is because it's a priority queue, it always takes out the smallest number that's in the queue, right? So if I add a bunch of things in there and I always take out the smallest one, that effectively sorts it. Do you see that? Okay, now the other thing that a priority that's neat about a priority queue is it can take a comparator. And so what's a comparator? So a comparator, it's kind of like comparable, right? So here's the comparable class that we saw before, right? And we remember how that works. It takes we get an integer a and b, and it's got this, and each of these things implements comparable. And so we can compare them using this compare to method, which has a less than 0 for less than, and a greater than 0 for greater than, and an equal to 0 for equal to. But sorry, the comparable method that we know and love has a compare to method, and it takes one argument and it returns these values. And when a class wants to know how to compare objects to itself, it implements this interface. However, suppose you don't want to use the normal way of comparing that's built into the class. You want to sort things in some different order. In that case, you need a comparator. So a comparator is something external to the class that you want to sort, and it has a compare method, and that compare method takes two arguments, and that returns just like compare to, a negative, a 0, or a positive. And when a class wants to compare any two objects, it asks the comparator what order they're in. So in this case, if I want to have a reverse priority queue, I want to reverse my order of integers, I can instantiate it with like this. And what do I see here? Somebody tell me.
Anonymous inner class.
Thank you. It's an anonymous inner class. And so I'm going to say new comparator, integer. So like a comparable, it takes this angle bracket with a type. And then I have a public int compare method. And this type here matches the type of these two arguments here. And in this case, to get the normal order, I would say return a minus b. But to get the reverse order, I get b minus a. And now when I add the numbers, it'll print the biggest one first. So let's look at that. Hold on. Right, so that's how that works. Any questions? Maybe you all need some coffee. Make you wake up and think of more questions. Yeah, I guess there's a problem with the sound today. I don't know what it is or why it's happening. So reverse priority is just the name of a class I invented. And the way it works is I created a new comparator object, and that's something that tells me how to compare any pair of items in the priority queue. And that pair of items should be of type integer. And so the compare method takes two integers and returning b minus a will give priority to the higher numbers, whereas a minus b would give priority to the lower numbers. This is the same logic that we saw with comparable. Does that help? All right, good. Okay, so here I have a screwed up sort of priority class. I call it priority 4. Let's get that code too. All right. So like all the other examples, it's going to get a priority queue. And the priority queue is going to add a bunch of random numbers, and then it's going to print them out. But what I've got is what I'm going to do is I'm going to give it a comparator. And I'm going to construct my comparator in this sort of classic way. I set a diff to 0. And if diff is 0, I say diff is equal to by 4a minus by 4b. Well, what's that? So what I'm saying up here is n% 4 equals 0. So I want to give a priority to something that is divisible by 4. And if one of these things is divisible by 4 and not the other one, then it should have a priority. If they both have the same result of by 4, then I print them in the ordinary order, a minus b. So let's look at that. Okay, so now you can see these things are not printing in the expected order, right? And let's modify this code slightly. Let me. So the idea is I'm showing here what the remainder is when it's what the modulus is with 4. And in this case, you can see that when I put the it sorts the 2 that are divisible by 4 to the top of the list, right? So that's what I've done with this class is I've made a special case where I can sort this type of thing to the top, but otherwise leave things in order. Any questions about that? Now you can imagine, quiz questions that use various crazy sortings for comparables, comparators, and so on. Please make sure you understand the difference between a comparable and a comparator. Any questions? You guys are like really low on questions this morning. I guess it helps if I can stare you in the eye and say, ask a question. All right. So here is an example of a comparable, right? Where I have a class coord2 that implements it. And what coord2 is going to do, oh, and I didn't use the angle brackets here, but I could have. Because I didn't, though, I have object here. And so I'm going to do a compare to object, and I'm going to say coord2 that equal coord2 object. Now, just a reminder, this thing that you're seeing here is called a cast, right? And that's how I convert something of type object to some other type. And if this obj thing is not of type coord2, my code will die at this point with a class cast exception. Okay, so now I'm going to do my comparison logic. And what I'm going to do is first I'm going to compare on the x coordinate and sort things that way. And if the x coordinates are the same, then I'm going to sort by the y coordinate. Here's another example. I'm going to do comparable, and I'm going to put angle brackets here with a type. And this is kind of mind-blowing, I guess, the first time you see it, because you've got a coord implements a comparable of coord. It's kind of recursive. But all that's saying, all that angle bracket is saying is that I want the argument to compare to be of this type, right? So I want it to be able to compare to itself is all it's saying. And so this code is otherwise the same as the previous one. Are there any questions? Just as a reminder, the fewer questions you ask, the more material I can cover. And if I get no questions at all, then I can even like find new material to add to test you on and so forth. So just keep that in mind when you're dutifully being silent. Okay, here is coord3. So this is going to be another coordinate type class, and it's going to be a comparable of itself. And I have a comparator. I have two comparators for it, and then I have it's also a comparable. So I have a final static comparator of coord3 called comp. And here's another anonymous inner class. And what it's going to do is it's going to sort by X and then by Y. And then I have R comp, which is like comp, but it reverses the order of A and B here. So it's going to do the reverse order search of comp. And then I'm going to make my compare to simply call this final static comparator here. So I've only described how to sort this forward in one place, but now I've got a comparator that I can generically use. And I've also got a reverse comparator that I can use if I want to hand it to a priority queue or a sort routine or something of that nature. Any questions? Sorry. My throat's really getting me at the moment. I see I have a question. Yes, I will explain that again. Give me just a moment here. Oh, shoot. It's not letting me go back. All right, just a sec. Okay. Sure. Okay, so what's going on here is the result of a comparison operation is something like a minus, right? So that's what we saw in our examples of our basic examples in previous lectures. So if I return a minus b from a compare operation, it's going to give me something. It's going to sort a and b in the correct order, right? So what I'm doing in this comparator, oh, let me back up. Comparator versus comparable. So a comparable is something that knows how to compare itself to something else. Whereas a comparator is something external that knows how to compare two things of a certain type. So a comparator is kind of like a consultant that you're bringing in. I guess you want to say, you could say students are comparable to each other in some fashion, right? And you know how to compare yourself to another student. And then your professor is somebody external who knows how to compare two of you to each other in terms of grade point average or something like that. Okay, so in this case, first we're comparing by the x coordinate, and then we're comparing by the y coordinate. And we're going to actually compare by that same ordering for the reverse comparator, except we're just have a sign difference here. Where this is a minus b, this is b minus a. So a comparator, again, is something that is not of type coord 3, but it knows how to compare things of type coord 3. And I have two of them here. And because I want this class to also be comparable, I have to implement this as well. But to save time, I'm going to make use of this comparator in this comparable function. Does that make sense? Does that answer the question? Kyle, does that answer your question? Yes, kind of. Okay, well, let me go back a minute and just remind you this class, right? This class shows you how comparisons work. So we have percent, and I encourage you to play with this code, right? So in the show method, which gets two integers, it's going to print out the two integers and the result, right? So a, b, and a dot compare to b. And a dot compare to b less than 0 means a less than b. And a dot compare to b greater than 0 means a greater than b. And if they're equal, they're equal. So you can think of compare to as minus, right? So a less than b equals a minus b, or a less than b equals a minus b is less than 0 equals a dot compare to less than 0. So this one is going to give something negative, right? And this one is going to give something positive, and this is going to give 0. You remember all this? Make sense? Does it help? All right. Okay, so places that we can use comparator. You can use them in sort routines. You can use comparators in sort routines. You can pass them as a second argument to a sort routine. And for lists, using the Java util collections, which has these static sort methods on it. And similarly, you can call the sort methods for arrays with a comparator as a second argument. So we've showed you how to write your own sort routines and how to write all these different things. But in real life, you'll probably just call sort. Just a sec. All right. So keeping track of the time, it is 10:01. All right. We also have some other things in Java util in this collections framework. We have set and tree set, map and tree map. And these classes, or these interfaces and classes are other places where you can make use of comparators. So a set is a collection of unique objects. And a map is an associative map of unique keys to non-unique values. We'll go into that in a bit more detail. And a tree map is going to be a version of a map that's based on a binary tree, and we'll talk about that in more detail later also. Okay, so one of the things you can do once you have the concept of a map is easily write a program to count words. And so let's take a look at how we do that. So in this case, what I'm going to do, I'm going to create a map of string to integer. And the idea is I want to use this map to store words and then the number of times that I've seen them, right? So I can look up, for any given word, I can look up the number of times I've seen it. So I'm going to, so notice, first of all, I'm going to throw IO exception for my main class. And that's because I'm going to use a scanner and a file object to read a file. So what I'm going to do is I'm going to go through each argument in the input to my main function. I'm going to pretend it's a file. I'm going to assume it's a file. I'm going to try to open that file and read it with a scanner. And then I'm going to use the has next and next method on the scanner to find the words in my input stream. And what I'm going to do is I'm going to say if the map does not contain that word, so there's this contains key method that tells me if that word is in my map. If the word is not in my map, then I want to put that word in my map. And I want to say that I've seen it once. If that word is already in my map, then what I want to do is I want to call get on the map with that word. And that's going to get the number of times I've already seen the word, right? I'm going to add 1 to that. And then I'm going to put that new value into my map with the same key, right? So I'm going to update the value of the number of times I've seen the word. And then I'm going to iterate through the map using this entry set, right? So entry set is going to be of type set, but set implements the iterable interface, so I can use it with an enhanced for loop. And so now I can say, system.out.println entry.getKey maps to seeing the word this many times. Okay. Did all that make sense to you? Do you have a question? Right. Okay. So I'll just re-explain it one more time. The idea is I want to count words. And so what I'm going to do is I'm going to count words in files. So I'm going to start with the main method. I'm going to take all the arguments passed to my file, and I'm going to read them with a scanner. So I'm going to say scanner equal new scanner, new file, right? So when I give the scanner a file object, you may recall that what it does is it opens the file for reading. Now I'm using the try parentheses block, so that will automatically close the file for me. I'm going to say while sc.hasNext, I'm going to read the next word. So this is just going to read through the file word by word. And what it's going to do each time it finds a word is it's first going to check to see if that word is in the map. If the word is not in the map, it's going to put it into the map with a value of 1, saying that means that so far it's seen the word once. If it's already in the map, it's going to get the number of times it's already seen it, add 1, and update the map. And then once it's got that whole thing read, it's going to print out the words, the key, which is the word, and the value, which is the number of times the word has been seen. The advanced for loop, the enhanced for loop, as you may recall, is based on something called an iterable. So if I have iterator, I'm sorry. So in this case, I have in this case, I have something called a map entry, but I'm not going to do that. I'm going to say, so if I have an iterator of a string, right, some iterator of a string, which could come from, say, a list. Okay, let's say I have a list of strings, right? Right, and I want to iterate through that list of strings. I can say for string s foo system.out.println s, right? That will print all the items in the list with an enhanced for loop. I'm not going to run this code, so I'll just put it like this. But what this is doing, when the Java compiler sees this, what it does is it creates the following code. Let's start with this one. So the enhanced for loop, this is a shorthand for this, right? And it can only be used on classes that have this method on them. That is, classes that implement iterable. Does all that ring a bell? All right, good. So maps, for each entry in the map, there is an iterator. There's the possibility, so when I call entry set, this is going to return a set of map entry objects, and sets are iterable. And so the enhanced for loop works. Okay, so let's take this this code that we have here and try it out. And one of my hobbies is that I like to write, and so I can do a word count on my book, right? So let's see my most common words. This is not good. Why is it? Hold on, let's do this. It's putting them in a fairly random, because it's sorting them by the order of the key, right? It's sorting them by the order of the key. So if I want to go through here, it's going to take me a while to find the most common words. And, so quote, thanks, comma occurs 8 times. Quote, thanks, comma, quote occurs 14 times, and so on. So this very simple program counts words, but you can see it doesn't really do things exactly the way you would like. I mean, its notion of a word is somewhat messed up, right? Because you don't normally want to include quotes and things in a word. So I have a couple other versions of it. In this one, we're going to use regexes. And remember the word character? That's an A to a Z, a 0 to a 9, an underscore. And That's what a W matches. Well, in this case, we're going to take one or more of them, and we're going to call. We're going to say that the result is going to come from the scanner. It's going to find all of those. It's going to convert them to a list and then use an enhanced for loop on them. And then this result is going to be a match result. And so now I'm going to have the same logic, except what I should get is things that match this pattern. Does that make sense? I guess it must, because nobody has a question. Okay. So now, if I want to count the words in my book, and now I get things that look more like words, right? Some of them are a little strange, maybe, but most of the time, I'm getting things that look more appropriate. Now, one of the things you might notice is I'm distinguishing capitalization, and maybe I don't want to do that. All right, let's see, what did I do here? So here I use a hash map rather than a tree map. Oh, okay. So what I'm doing in this case is I'm sorting the words by frequency at the end. So, I got all the words more or less the way I wanted. The problem is that it's hard to find the ones that get used the most often. So what I did, right, is when I went through here and I did this find all thing, I went through and I did the same logic that we had before, really. But when I came to the end, I created a list. I put all the words into that list, and then I want to sort them, and I want to sort them by the frequency. And how do I do that? Well, what I do is I pass this comparator in, and this comparator is a static object, right? It's a static object I created, and I've got a compare method that looks into the map, which is also a static object. So I've got the map and the comparator all as static objects, and I'm finding the number of items in the map with this method here. And so I'm doing this to do the comparison. And once I've got a comparator that can do this, then I can print out the words in the correct order. I have a question. The last one did not include quotes and commas, and the reason it did not was because I used a regular expression to match a word. So this is only finding things that match this pattern, which is going to be letters, numbers, and underscores. Does that help? How would you construct it for contractions and compound words? Well, compound words, I think, are going to be by default. But what I could do, right? If I wanted to include those things, I could put A to Z, A to Z. I could put an apostrophe in there. I could put a minus in there. Apostrophe is going to include the contractions. The difficulty, of course, is it's kind of hard to compare to distinguish that from a single quote. But you can also do this, right, which will give you everything as a lowercase, and it will stop distinguishing things by upper and lower case. So you could change the regex if you want to include, hyphens and apostrophes. And now it's showing me the words. It's going to put the longest ones last. So the occurs 5,432 times. And these are all the sorts of words you would expect to be the most common, I suppose. Maybe the word train is a standout in this novel. Anyway, any questions? I'm sorry about your internet. All right, so the idea is, so this is a hash map. I haven't really talked about that, but it's just another map. It works the same way. Everything that has this interface kind of works the same way. Here is a comparator, and what the comparator is going to do is it's going to compare the words by how frequently they occur. So it's going to take these two objects, it's going to cast them to strings, and then it's going to call this toInt method. And this toInt method is going to just get the value out of the map. And if it's not in the map, it's going to get a 0. So that's how many times it's seen the word. So that's how we compare by frequency. And this code here is largely the same as the code that we had before. It's just, going through using the scanner and the regex to get all the words. The difference is that I used a slightly different regex here to get, apostrophes and hyphens. And I used to lowercase here so that I don't distinguish words by, the word that from that if it happens to what happens to be at the front of a word. Otherwise, this code is all the same. Once I have this map populated with words and frequencies, I can get all the keys, that is all the words, out of the map, and I can add them to a big list and then call collections.sort on them with this special comparator that I made. Does that help? Does that help? Good. Okay. All right. We're almost to the end of our time. 10:19. Yeah, okay. This is pretty much where I should call it. And we'll pick up here at the next time. Are there any final questions? Yes, I can show the first one and why it includes commas and quotes. So what it does is it doesn't use a regex at all, right? It uses scanners, has next and next. And what that's going to do is just going to find anything that's separated by white space. And that's why it includes all those other funny characters. Does that help? All right. I'll see you all Wednesday. With any luck, I'll see you in person. Have a good one. Thanks.